Hey, and welcome. Have you ever stopped to think about how your computer can stream music, download an email, and let you browse the web all at the same time over just one single internet connection? It really feels like magic, doesn't it? But it's actually an incredibly clever system of, well, digital organization. Today, we're going to pull back that curtain and see exactly how it all works.
Welcome to SuperCore. Unlock the secrets of the internet and master computer networking. Let's dive in.
I mean, really think about your average day. You've probably got Spotify playing, maybe a Zoom call running, and a dozen tabs open in your browser. All of that data is flowing through one pipe, yet it never seems to get mixed up. How does your computer keep it all from turning into a complete digital traffic jam? That is the exact question we're going to answer right now. So, the secret sauce is deep inside your computer's networking system, in a part of the stack called the transport layer. And the best way to think of it is as a super efficient, super smart traffic sorter, directing this constant flow of information with just incredible precision. Now, this traffic sorter manages a two-way street. When you're sending data out, it performs something called multiplexing, basically taking all the data from your different apps and funneling it into one single stream to send out. And then when data comes in, it does the exact opposite, a process called demultiplexing. It takes that mixed up stream of incoming data and carefully sorts it, handing each little piece to the right application. You know, this packet goes to Chrome, that one goes to Spotify, and so on. Okay, but how? How does the sorter know where to send each piece of data? Well, the whole system relies on a brilliantly simple addressing tool, port numbers. So a port is basically just a unique internal address. It's a 16-bit number, and it gets assigned to every single app or service that needs to use the network. It's the little signpost that tells the transport layer, hey, this specific program over here is waiting for this piece of data. And this brings us to what is probably the best analogy for understanding how all this works. Just think of an IP address as a skyscraper's street address, and a port as the specific office number inside that building. The IP address gets the mail to the right building, but it's the port number that gets it to the right office. Let's break that down. First up, the IP address. This is the unique identifier for your computer on the vast global network of the internet. It works exactly like a street address, making sure a data packet arrives at the correct machine, the right skyscraper on the block. But, once the packet arrives at the skyscraper, that's not enough, right? It needs that office number, and that's the port. It tells your computer precisely which application gets the delivery. So port 80 might be your web browser, while port 587 could be your email app. So you see, neither the IP address nor the port number is quite enough on its own. It's the combination of the two that creates a complete, totally unambiguous address for any communication on the network. And when you combine an IP address with a port number, you create what's officially known as a socket address. That right there is the complete, unique endpoint that specifies not just which computer to talk to, but which application on that computer to talk to. And the format couldn't be simpler. It's just the IP address, followed by a colon, and then the port number. This simple combination is literally the foundation of how billions of devices and apps talk to each other every single second. So next time you see an address that looks like this, you can translate it in your head. It's just an instruction to the network that says, hey, deliver this data packet to the computer at address 10.1.1.100, and once you get there, hand it off to whatever application is listening at door number 80. Simple as that. Now, just like a big skyscraper has a main reception desk on the ground floor, the internet has standard well-known ports for common services. These are basically universally agreed upon numbers so computers don't have to guess where to go. Any device on Earth wanting to browse a website knows to connect to port 80 for HTTP. Need to send an email? It'll look for port 25 for SMTP. This standardization is what lets totally different systems all over the world talk to each other seamlessly. So this system isn't just a neat theory, it has huge practical benefits for efficiency. Let's look at a quick real-world scenario to see just how powerful this all is. Okay, imagine a small business. They've only got one physical server. That's one computer with one IP address. But thanks to ports, that single machine can do the job of three. It can host the company website on port 80, it can run the email server on port 25, and it can manage the file server on port 21, all at the exact same time. It's just incredibly efficient. And most importantly, that traffic sorter we keep talking about, the transport layer, it uses these port numbers to make sure nothing ever gets mixed up.
It guarantees that emails from customers land in the mail server and that requests to see the website are handled by the web server. It's what prevents total and utter chaos.
So there you have it. The secret to the internet's multitasking ability isn't magic at all. It's just a really clever system of street addresses and office numbers. Now that you know about ports, it kind of makes you wonder, what other invisible rules and architectures are quietly making our entire digital world possible?